All right, so topic number 2, so 3.2, is about solubility. So we're still going to be talking about dissolving ions in solution, but solubility equilibrium. So what is solubility equilibrium? Well, it's a type of dynamic equilibrium, meaning that there is still movement, occurring when a solid compound is in equilibrium with its dissolved ions in solution. What does that mean? Well, in Chem 11, we always talked about the fact that solutions can only hold so much. So there is a maximum amount of a substance that can dissolve in a given amount of solvent at a given temperature. You know that you've got the maximum amount in there when extra solid stays undissolved. In Chem 12, instead of talking necessarily about the maximum amount of substance dissolved, we're going to talk about when you reach equilibrium. So we're going to talk about when we reach this equilibrium concentration of a solute in a solution at a given temperature. And we're going to express this in terms of moles per liter. Let me just show you an example here. So an example of this would be dissolving salt. So sodium chloride is an ionic compound, right? We talked about that in the first lesson. It's a metal and a non-metal. And when you place it in water, we looked at that video and saw that the water molecules are going to attract the ions so that the salts are going to begin to dissolve, right? The negative oxygen end is going to attract the positive sodium, and then the positive hydrogen end is going to attract the negative chlorine. And so what's going to happen is that your NaCl solid is going to dissociate into sodium and chloride ions. And we're going to let it do this, right? We're going to see what amount of this sodium chloride can dissolve. And you're going to watch this because the amount of that solid is going to decrease and decrease and decrease. And that would be the end of our Chem 11 story, right? We would just be like, okay, now we're done. What's going to change with the Chem 12 story is what happens next. Over time, these dissolved ions will start colliding with the crystal and with each other. And some are going to get pulled back, meaning they're going to re-solidify. We call this precipitation, which means that the sodium and the chloride ions are going to precipitate and form sodium chloride solid. And what we're going to wait for is the point that this dissolving and crystallizing or precipitation is happening at equal rates. Then we'll know that we're at dynamic, right? If we want to throw that word in, dynamic, because there is dissolution, there is precipitation, equilibrium, because as soon as your solution is saturated, you're going to have this forward and reverse reaction, which we would show with a double arrow, right? We would have the sodium chloride solid dissolving into the ions, but then we would also have the ions precipitating or crystallizing as the sodium chloride. So from these pictures, at the beginning it was a one-way street, right? We had this dissociation of ions. We got sodium and chloride floating around. But as time happened, we would start having this recrystallization where all of a sudden solid would form. And then we will know we're at equilibrium when we've theoretically got the max amount of ions dissolved in solution, but from the Chem 12 perspective, we'd be at equilibrium, meaning the rate of dissolving would equal the rate of precipitation or crystallization, right? Awesome. So what type of solutions can we form? Well, there's 3 types of solutions that we will be looking at. The first one being supersaturated, which we're looking at here, but we're not going to actually do any math on. And this is when you have more solute than normally dissolves. So you'd have more salt dissolved, so more ions than the solution should theoretically hold. It's incredibly unstable. And if you disturb it at all, it will crystallize. And I've got this really cool video of this happening. Okay, so what we've got here, you can't tell, but this is a flask of super saturated material. And so it's sitting here, it's all happy, but as soon as you disturb it, things happen. So here you go. The video keeps going, but you get the idea from that, is that it was just a liquid holding a certain amount of dissolved ions. But as soon as we did something to disturb it, and so then the things started precipitating, there was a precipitation cascade where everything just started precipitating on top of each other. And so then all of a sudden you got this crystal development. Okay. Now, again, they're super cool, but we're not going to cover them. What we're going to be looking at in this course is unsaturated versus saturated solutions. So an unsaturated solution is one that is holding less solute than the maximum. There's no solid present and you wouldn't be at equilibrium. What would that mean in a practical sense is if you put some sodium chloride into, well, why would you put salt into water? Let's say sugar. Okay, you were sweetening your tea and you put sugar in it and you added just a little bit just to sweeten it a little bit. You could have sweetened it more. There was room for more sugar to get dissolved in your tea, but you just wanted a little bit. Saturated is like you want a sweet tea. You're going to make that tea hold as much sugar as it possibly can. So what'll happen is you stir in a whole bunch of sugar and some of it will dissolve. The maximum amount that can will dissolve, but then there'll be some undissolved solid at the bottom. So when you get that last sip of tea, it is really sugary because there's a bunch of undissolved sugar at the bottom of your cup. When you do that, so when you've poured in enough sugar that there is solid sugar at the bottom, your solution won't naturally supersaturate. You have to do something special to make that happen. Your solution will saturate. It will dissolve as many of the ions as it can, and it'll have some undissolved solid at the bottom, and then you'll reach dynamic equilibrium, meaning the rate of dissolution will equal the rate of crystallization. So what are the features of a saturated solution? Well, from the macroscopic level, you're not going to see a lot. There's going to be no visible change in the solid at the bottom, and it's going to be a constant concentration in your liquid. But at the microscopic level, the rate of dissolving, so the forward reaction, will equal the rate of the precipitation or crystallization, which is the reverse reaction. Now, keep in mind, this is a great kind of multiple choice type question, is that equilibrium can take a long time. Right? So maybe you put a bit of sugar in your tea and you drank it right away. Well, you didn't saturate it as much as you could have. If you'd left it for a longer period of time, now make sure that temperature isn't a factor here, but if you left something at a constant temperature, there could be more that could dissolve, but equilibrium can take a while. So for you guys, just a key thing to be aware of is that the conditions for saturation to be reached is that you'll have some undissolved material at the bottom, and that means that equilibrium, and you've left it for a period of time so that equilibrium can exist between the dissolved and the undissolved solute.